Okay, so let's start adding a little bit of details in terms of the, oops, why is it, okay, in terms of specific climate stressor. Let's start with heat waves and move to air pollution and so on. So this is showing trends in seasonal heat waves and length of the longest heat wave, average intensity and cumulative intensity. So these are in days per decade, these are in degrees centigrade per decade. So if there's a spike on one day, it may not be as bad, even though it does have serious impacts based on your vulnerability. And the cumulative intensity is when it persists for a while. Okay, that can make things pretty much worse for everybody, right? So these are from two different data sets. So you can see there are some serious differences. This is from the Berkeley Earth data set, and this is from the HADG Global Hydroclimatic Network from the East Anglia University, I think. Okay, it doesn't matter. You can look up the sources. So you can see that you immediately see there are disparities across the planet. The deep tropics and the poorer countries on average have a much stronger trend in heat wave days, length of the longest heat wave, and average intensity, as well as cumulative intensity. These are the Middle Eastern and North African regions, generally known as MENA, Middle East and North Africa. They are generally kind of hotspots for geopolitical issues, let's say. And a lot of these countries rely on oil income, and here there is generally more poverty, depending on with specific country. Nonetheless, you can imagine that in the future, if it gets warmer and warmer, and let's say at some point oil begins to either be replaced by renewables or actually runs out, then you can see what kind of issues it'll create in these places. Okay, already these are hotspots for various conflicts, as I said. Okay, India, an economy that wants to grow. China, an economy that's wants to continue to grow, obviously have to face issues as well. You can see here cumulative intensity per decade has increased as far north as Mongolia into Russia, Japan, and so on and so forth. Europe is having many issues. The 2003 heat wave, I think, in Europe caught them by incredible shock because they didn't expect so many tens of thousands of people to die. They obviously were thinking they are not vulnerable to climate impacts. Okay, so when we do these things, there are what are called detection and attribution of climate change. What does that mean? We are saying, for example, this is a trend observed in some data. Okay, that means you are claiming you have detected a signal, a change signal in the heat wave days, longest heat wave, length of the longest heat wave, average intensity, and cumulative intensity. Now, attribution means you have to say if that was in fact caused by human activities, global warming, right? So there are ways to do that. Typically you take a model and you include the human forcing like greenhouse gases and then simulate these heat waves. Remember, we already showed how the heat waves are captured by the models, and that gives us confidence for projecting them into the future. So in attribution, you put in the CO2 and look at the trends, and you remove the CO2 and you look at the trends. And if the change is caused because of increased CO2, then you say yes, it is related to human activity. But there are details. For example, a Siberian heat wave of 2010, was the probability of the heat wave increased or the amplitude of the heat wave increased? So the questions are not necessarily the same. Heat waves can occur naturally, But if they're being made stronger, for example, length of the heat wave is being increased or the intensity is being increased, but the probability of occurrence is not being increased, then you have to be able to separate them. Climate change is not increasing the probability of heat waves, but it is making them more intense and make them last longer. Right? So those kind of details have to be carefully considered as well when we do that. We'll look at the impacts of these on health wave in terms of direct and indirect impacts. So these are health impacts of exposure to extreme heat. So direct impacts, obviously there are heat illnesses like dehydration, heat cramps, heat stroke, accelerated death from respiratory diseases, cardiovascular disease, and other chronic diseases like mental health and renal diseases, kidney failures, and so on. Hospitalizations because of respiratory diseases, diabetes mellitus, so there is an interaction between extreme heat and diabetes, and kidneys, of course, because it's the hydration of the body, strokes, mental health, and so on. Indirectly, heat wave, extreme heat would affect the health services, so more ambulances will be called out and response will get slower, so that can cause heat cramps. The response times are affected, increased number of hospital admissions. Storage of medicines can become an issue if there are no refrigeration facilities. Increased risk of accidents like drowning, work-related accidents, injuries, poisoning. People working in factories without proper ventilation, people working outside as farmers. This happens a lot in India in the pre-monsoon season when it's summer happens. When monsoon comes, temperatures cool down. Pre-monsoon season, March, April, May, is when farmers are outside trying to clean up the field to get ready for the sowing for the monsoon season. So that can create lots of mortality related to heat waves. Food and waterborne diseases, marine algal blooms, disruption of infrastructure, the power demand goes up, power failures can happen, power outage happens in countries like India, Pakistan, and so on. Water, quantity, quality, availability, transport, productivity, right? There's a serious impact on labor productivity during heat waves. Okay, so those are the direct and indirect impacts of heat waves. I'll stop this here. Maybe add air pollution. No, let me add this one here. Sorry about that. Working hours lost to heat stress by subregion. So this is projections into 2030, so you can see where the data comes from and which model is used for the projections for 1995 and projections out to 2030. And different regions are being looked at, like Southern Asia, Western Africa, entire world here, and so on. And the most consistent news, of course, is by 2030, the working hours lost due to heat stress are going to increase in pretty much all regions. Okay, there are regions where the impacts are not so strong because they're already pretty warm and they're not going to get much warmer or something like that. We have to carefully consider the details. So you can see that this is 5.3 hours lost. I think this may be annual number of days. We have to be careful. And the projection assumes a temperature rise of a global average of 1.5 degrees centigrade. If you change that to 2 degrees, it's going to increase much more. Okay, so that just confirms what we said here, that there is productivity loss because of heat waves. Okay, I'll show another plot which is important, which I have to bring back in, which relates to how temperature rise is related to also humidity rise and how that makes life much more complicated. Okay, let me do that in the next podcast. Sorry, this is a bit discontinuous, but I think the points are clear.